All right, so welcome to this video. We'll be looking at how to solve quadratic equations using different methods. Okay, so there are a lot of methods that we use to solve quadratic equations. Okay, there's factorization method, there's completing the square method, which is the most important one. And then there's the one where you use the quadratic formula, usually for the quadratic equation that has non-whole number roots. Okay, we use the quadratic formula. Okay, so those are the three, and then we also have other ones like graphing. You can solve these quadratic equations by graphing, blah blah blah, and the like. But the main ones are factorization, completing the square, and the quadratic what formula. Okay, so this question here says solve the following quadratic equations using factorization, completing the square, and then quadratic formula what methods. So meaning each of these we can try to use these formulas here, but not all formulas are going to work for everything here. So the one that has a limitation actually is the factorization one. Okay, so the factorization one, um, it uh, it requires that the quadratic equation always has whole number roots, okay, or it has whole number answers. So it's limited in that way. But using the completing the square or using the quadratic formula, you can find the answers to any quadratic equation. It doesn't have what? A limitation. All right, so we'll solve some of these questions here using factorization. We'll solve some using completing the square, and then we'll solve some using what? The quadratic formula. But what I want you guys to know is that no matter the method that you are going to use, you're still going to find the same answer. Okay, so like for the first one there, we are going to solve it using three methods so that you just know that, okay, it gives the same answer. We're going to do factorization, okay, the one that you are doing at grade 12. We're going to do completing the square, and then we're going to do quadratic formula. You're going to see that it will just give us the same answer. Okay, so let's start with the first one there. So that is 2x squared minus 7x plus 3 is equals to 0. So if we're using the factorization method, then we have to find the product, the factor, and the what? And what we call as the sum. So for the product, you have to multiply the coefficient of x squared with the constant. So maybe I should have written here. So the general form in which we write a quadratic equation is ax squared plus bx, and then plus what? C is equals to 0. So now this C here is a constant because it doesn't have any x. Okay. And then B will be the coefficient of x, and then A will be the coefficient of x squared. Okay. So the product, we always find it by multiplying A and C. A is the coefficient of x squared, and then C is the constant there. So if I multiply here 2 multiplied by the 3, what do I get? I'm going to get 6 as my product, right? Okay. And then the sum, this S here, is always the coefficient of x. So the B is always the sum. So now when I go here, my sum is what? Okay, what is the coefficient of x here? We see that the coefficient of x here is just minus 7. So by coefficient, we simply mean the number in front of the x. So you can see here, in front of the x, there's minus 7. So that is my sum. Okay. All right. And then now the hard part comes, or the challenging part, where you have to find the factors. So now the factors are just two numbers, okay, such that when you multiply these two numbers, you should get the product. But when you add them, you should get the sum. Okay. So you are going to look for two numbers such that when you multiply, you get the product. Okay. And then when you add them, you get the sum. Okay, so it's a trial and error method. There's no standard way of knowing, okay, these are the factors and the like. It's just a trial and error method. Okay, so for this one here, who can try? What do you think are the factors there for this question? Anyone who can try?
It's negative 6,
That's
negative 1,
negative 6 and negative 1.
Yes. Yeah. So here we put -1 and then -6. So you see, if I multiply -1 and 6, I'm getting a positive 6. Nice. If I add -1 and -6, I get -7. So those are my factors. Okay, so now once you have those my factors, you just come here and replace the term with x with those factors. So what you're going to do is that you're going to write 2x squared, and then this guy here is -7x, right? So you write it in terms of the factors that you written there. Okay, so I'm going to write this minus 7 as minus x minus 6x and then plus what? 3 is equals to 0. So you've seen that I haven't changed anything, but I've just written the minus 7 here in terms of its factors like that. Okay. Right, and then from there, you're going to group these things, okay? So the first two terms, they go together, and then the other terms there that are remaining, they also go together. And then now you do the factorization. Then you ask yourself, what is common here? Okay, I see what is common here is just an x. Because there's x here, I can also see x there. So I'll factorize the x, okay? Then what do I remain with here? I remain with the 2x, and then minus, here if I factorize the x, I remain with the 1. Okay, what about in these brackets? What is common? Okay, what is common there is just a minus 3. Okay, so if I factorize a minus 3 from here, I remain with the 2x. And then if I factorize a minus 3 from positive 3, I'm going to remain with the minus 1. Okay, so the goal here is actually to always get the same thing in the brackets, in the two brackets that you're forming. So in this bracket and this bracket, they should always be the same thing. Okay, then you are doing the correct thing. So you're going to write the thing that is appearing twice. You're just going to write it as one factor, and then you get whatever was outside here, you combine them. So this is x, okay, with the minus 3. And then this is equals to 0. Okay, and then now to find the values of x, I'm just going to equate this to 0, I solve for x. I also equate this to 0, I solve for x. So it will be like 2x minus 1 is equals to 0. Okay, and then I solve for x. So that will be 2x is equals to 1. I divide both sides by 2. I'm going to get x is equals to what? 1 over 2. Okay, so that's my first answer. My other answer, I'll write it here to be x minus 3 is equals to 0. So that will just be what? X is equals to 3. So meaning that my answers to this quadratic equation here are simply x is equals to 3 or x is equals to 1 over what? Half. Okay, so any question there on the factorization? Okay, so if there are no questions, we look at... Oh, someone has a question.
Yes, I have a question on finding the factors. Like we looked for -1 and -6. Is there any other method apart from this?
What?
Let me finish up.
On
There's
fi
this one of using us.
Yeah, you're saying how
Is
can we
it the
find the
same?
factors using another method?
Yes. Is it not the one where we multiply us times of the coefficients, which is -7, then you multiply by half, or maybe I'm mixing things up.
Just come again. You said we multiply the -7 by what?
Like you just get the -7, which is the coefficient. You just
Uh-huh.
get -7 instead of finding like we found -1 and -2.
Uh-huh. So we get
And
-7
-1
and
and
what?
-7 times half.
Times half.
Yes. Is
Oh,
it the
no, no,
same
no.
method?
That one is completing the square. So you're mixing them up.
Uh,
Yeah. So that one
yes.
is completing the
Uh,
square.
uh,
Yeah, Mr. Vincent, you have a question?
Yes, sir. There is this question that I came across recently.
Mm-hmm.
It was challenging some. It was like -x squared plus 6x minus 3. Now, the difficulty now to find the factors. Yes, sir.
Mm-hmm.
Because there are some questions whereby we are not given the factors. It's very challenging to find the factors. So kind of asking if you can solve it roughly.
Okay, so that's what I was saying. I was saying if you're using the factor method, the factor method is limited. It doesn't work for all the quadratic equations. Okay, it doesn't work for all the quadratic equations, but the completing the square or the quadratic formula works for everything. So I don't know if the question that you had factors, but you can just say it. I try to write it here. But it was like what? Minus x squared
Yes, -x squared plus 6x minus 3.
plus 6x minus 3. Okay, so you can try to find the factors here. but I'm seeing this one doesn't have factors because the product here will be positive 3. If I multiply -1 and the -3, right? And then the sum is 6. So now, what two numbers can I add to get 6, but when I multiply them, they give me a positive 3? There are no such numbers. So it means this one here, you can't solve it using the factor method. You can only solve it using completing the square and the quadratic formula.
Okay, I understand.
Yes, so it's not all the quadratic equation that you can solve using the the factorization method. The factorization method is limited. It only works if you have some particular factors there. Okay, so we solved this question here using the factor method. Okay, let's try to solve it using the quadratic formula. We see if we're going to get the same thing. So quadratic formula is x is equals to, okay, minus b plus or minus the root of b squared minus 4 ac divided by 2a. I'm sure all of us know this formula, right? So it's called the quadratic formula. Yeah, so some of you were saying Chibas formula, some were saying Chim40. This is the quadratic formula here. So now, the way this quadratic equation has been given here, we can find the value of a, b, and c from this same quadratic equation. So generally, ax squared plus bx plus c is equals to 0. So meaning that the coefficient of x squared is always my a. So in this case, my a will be what? 2. And then what will be my b? My b will be the coefficient of of x here, which is just -7. Okay. And then the c is the constant there. So c is equals to what? To 3. Okay, so meaning that what I'm going to have here is x is equals to minus, okay, be careful with the minus there, okay, because some of you, will see that the b has a minus there, and then here you just write -7. No, so the minus there is in the formula. So there's this minus there, I put the minus, and then what is my b now? So you always put your b in brackets so that you don't get confused. So my b is -7, so I'll put a -7 there, okay? So don't be confused there. And then you say plus minus the root of b squared. So that would be -7. I square it minus 4. And then I multiply by a. A is what now? A is 2. And then c is 3. Okay, so that's what I have. And then I divide through out by 2, multiply by a. So this is going to give me x is equals to negative and negative, I get 7, and then plus minus, okay, the root of, this is -7 squared. So that would be 49 minus 4 multiplied by 2 multiplied by 3. What is it going to give me? So this is like 6 multiplied by 4. So that would be 24. Yeah, and then I divide this by 4. Because when I multiply this here, I just get what? I just get 4. Okay, and then from there, what are we going to have? Okay, so we are going to have x is equals to 7 plus or minus. What is 49 minus 24? That will give me the root of what? 25, right? And then divided by 4. Okay, divided by 4. So now what is the root of 25? So the square root of 25 is just 5. So I'll put 5 there. Okay, so meaning that x will be 7. I get the one with the positive plus 5 divided by 4. Or it can be x is equals to 7 minus 5 divided by what? 4. So you see that from here, I'm just going to have 7 plus 5, that will be 12. Divided by 4, this will give me 3. Or x is equals to 7 minus 5, that will give me 2 over 4. This will still give me what? Half. So you see that even the quadratic formula is actually giving us the what? It's giving us the same answers. Okay. Yes. Someone has raised their hand.
Okay, so sir, like I can use quadratic formula on all these questions.
Yes, you can use the quadratic formula on anything.
Yeah, it's much better compared to the one we are using, but it's also fine now. The problem is when finding a factor product ish.
Yeah, so the problem only comes in if actually the question says use a specific method. So you have to know all the methods. So they can say solve this quadratic equation using completing the square. So you'll be forced to use completing the square. Or they can say quadratic formula, or they can say factorization. So just to be on the safe side, you have to know all the methods. Okay, Mr. Vincent, you raised your hand. You had a
So
question?
does it mean
Hello, sir.
Yes,
I
you
don't
had a
have a
question?
question.
You don't have? Oh, okay.
it's me that was I wanted to ask. So the question is asking us to solve using any of the any either factorization, completing the square, or quadratic formula. I can use any.
Yes, we can use any.
Is it what the question is?
Huh?
Okay.
Okay. Yeah, so these here you can use any. Okay. All right, so now let's try to look at complete the square. So guys here, pay attention because here that's where most students have challenges on completing the square. So completing the square is very simple. You just have to follow the rules that I'm going to tell you. Then you are good to go. Okay. So when you're completing the square, what you need to know is that first, let me write the general form of a quadratic equation. Plus c is equals to 0, right? So when completing the square, the coefficient of x squared here always, okay, always has to be a positive 1, okay? When completing the square, the coefficient of x squared always has to be a positive 1. So if you are given a question, okay, where the the coefficient of x squared is not a positive 1, you need to make that coefficient to be what? A positive 1. So you can do that by factorizing if it's just given as a function. But if it's given as an equation like that, you can make that coefficient to be a positive 1 by just dividing by the coefficient of x squared that is currently there. Okay? And then now, once you make the coefficient of x squared to be a positive 1, then you start completing the square now. Okay, so always make the coefficient of x squared to be a positive 1. If you can't make it that, then there will be nothing that you'll be doing. You won't be completing any square. Okay, so now look at what we've been given there. So we have 2x squared minus 7x plus 3 is equals to 0, right? Okay, so this is what we have. So I noticed that my coefficient here on x squared is not a positive 1. So I need to make this here to be 1. So what can I do? So if you are given an equation here, meaning it's equals to 0, you can simply just divide everything here by the coefficient that is currently there. So I'll divide this by 2. I'll divide this by 2. I'll divide this by 2. I'll also divide this by 2. I'm just trying to make this here to have a positive 1. So 2 divided by 2, that will just give me a 1, which is a positive. So I have x squared and then minus 7 over 2x and then plus 3 over 2 is equals to what? 0 divided by 2, that is just 0. Okay, you've done the first step. Okay, and then now the second step is to form what we call as a perfect square. Okay, to form what we call as a perfect square. No wonder we are saying completing the square because we want to form a perfect square. So how do you form the perfect square? Okay, you're going to write the way this quadratic equation is. So x squared, then you say minus 7 over 2x, okay? And then now you add what we call as a special 0. It is a 0, but it is represented in terms of numbers. So for example, if I say 10 minus 10, 10 minus 10 is a 0, but I'm representing it in terms of numbers here, okay? So I'm going to say this here, okay? I'm going to create what I call as a special 0 now. So now, how do I create this special 0? Okay, so you create the special 0 by saying you get the coefficient of x. So what is the coefficient of x here? Coefficient of x is minus 7 over 2, right? Okay, so you get the coefficient of x, you divide it by 2, and then you square this expression like that. Okay, get the coefficient of x, whatever it is, divide it by 2, and then square the expression. Okay, and then now the expression that you're going to have here, add it and then subtract it. So like we are adding the same thing and then subtracting it again. So that's why I'm saying it's a special zero. Okay, you get the coefficient of x, divide it by 2, and then put it in brackets like that, square it, and then I'm going to add it and subtract it. Okay, so now here I have like minus 7 divided by 2 and then divided by 2, right? So dividing by 2, it is the same as multiplying by half. So this is the same as I multiply this by half like this, and then I say squared. Okay, so whatever I wrote here is the same as this. Dividing by 2 is the same as multiplying by half. Okay, so if I say 10 divided by 2, that is 5, right? If I also say 10 multiplied by half, it will still give me 5. So dividing by 2 is the same as multiplying by half. So some books or some lectures will tell you multiply by half. Some others will say divide by 2. It's the same thing. So the expression that I have now here, okay, look what I'm going to do with it. I'm going to add it and subtract it. Okay, so here I can even multiply whatever is inside. So that is minus 7, and then 2 multiplied by 2, it's 4. So I'm going to say I add this and then I what? I subtract it, right? So I'm going to say plus, okay, minus 7 over 4 squared, and then minus 7, minus 7 over 4 again, and then squared. And then I continue with my equation, plus 3 over 2 is equals to what? To 0. So I've even put that in a different color so that you just get whatever is happening, right? So you've seen that this part here, this is just a special 0, right? So meaning I've not changed anything in my equation. I'm just adding a 0 there, but it's a special 0. I'm representing it in some form of numbers. Okay? All right. So here now what is going to happen is that once you make your special 0 here, as long as you've made the special, as long as you've inserted the correct special 0, always these first 3 terms here, from the x squared to the first term in the special 0, they are going to form what we call as a perfect square. Okay? They are going to form what we call as a perfect square. So to simplify a perfect square, we always consider the terms that are squared. So this is x squared, and then this is minus 7 over 4 what? Squared. So they are the only things that we are going to consider. This guy here, we just ignore it. Okay, I can just say ignore it. So I'll just get x here, it as a square. I'll just write it as x, and then I'll get whatever is in the brackets here, which is minus 7 over what? 4. And then I'll say, okay, these are the square, even these are the square. So I'll put these in brackets, and then I'm going to say squared. Okay, are we following the story there, guys?
Yes, sir.
Okay. And then once you do this now, you're going to write whatever has remained. So that is minus. Okay, and then inside there I have minus 7 over 4 squared, and then plus 3 over what? 2 is equals to 0. Okay, so it means you've completed the square. Okay, it means you've completed the square. So now to solve it, to see if it's going to give us the correct answer, let's do that. Let's solve it. Okay, so in the brackets there, I have x minus 7 over 4 squared, and then minus, and then now you can distribute this power here to the minus 7 and to the 4. So if I say minus 7 squared, I'm going to get 49, okay, divided by, if the square goes to the 4, I'm going to get what? 16, right? Okay, and then I have plus 3 over 2 is equals to 0. Okay, so meaning here I have x minus 7 over 4 squared. Okay, and then I take these guys to the other side. So it will be equals to, this was minus, it becomes positive. And then this was positive, it becomes minus. Okay, so that I have x minus 7 over 4 squared is equals to, here I can add these, right? So my common term there is what? Is 16. So 16 into there, it's 1. 1 multiplied by 49, I get 49. Minus 2 into 16, it's 8, right? And then 8 multiplied by 3, I get 24. Okay, so what do I have there? I don't want to erase this part because some of you might have questions. So I'll just write down here. So meaning that I have x minus 7 over 4 Okay, squared is equals to, on top there, 49 minus 24 gives me what? 25 over 16. Okay, but my aim is to find the value of x, right? So when I reach there, I'm just going to say square root this and then also square root that. Okay, but this part here that does not have the square initially, I'm going to add a plus and a minus in front. Okay, here I can't add a plus or minus because I have this square here. Okay, so what am I going to do now? So this square and the square root will cancel. So I have x minus 7 over what? 4 is equals to, and then here I have plus or minus. What is the square root of 25? It is 5. What is the square root of 16? It is what? 4. So that is what I have there. Okay. Okay, yeah, I think I lost network. Someone was calling my phone. But it's a network guy watches on. Yeah, so I think we can continue. So I don't even know where I ended on. Yeah, but we're trying to just complete the square, right? Okay, so I was saying here I have on my right hand, on my left side, I have x minus 7 over 4. And then on the other side, I have plus or minus 7 over what? Plus or minus 5 over 4. So I want to find my value of x. So it means I'll transfer this guy to the other side. So what am I going to have? Okay, I can erase now here. So I'm going to have x is equals to 7 over 4 and then plus or minus 7, 5 over 4. So you see that we're still going to get x is equals to, if I get the positive one, it will be 7 over 4 plus 5 over 4. So 7 plus 5, that will be 12 divided by 4, okay, which will just be 3. Or if I get the negative here, it will be 7 minus 5, that will be 2, and then I'm dividing by 4. So that will be x is equals to 2 over 4, and then this reduces to what? 1 over 2. So you see that I still get the same answer of 3 and minus 1 over 2. Yeah. So it doesn't matter the method that you use, you still get the same answer. So any questions there on how to complete the square?
So this one, it's just fine, but it's long.
Yes, it's long and that's what will come in your test.
So I've got two questions.
Yes, you can ask.
Yes, the first one is on the special zero there.
Mm-hmm.
Yes, where we are putting where we had put negative 7 over 4 square root. Not like two of them at one. Close to each other, next to each other. So is it okay if we put one there, then the other one, the second one we place it at the end of the equation,
Yes, it's
but
okay.
before they equal to 0. That's okay.
Before they equal to 0,
Yes.
like on the same side, no, it's not okay. Okay, so you were saying we place this guy here just before the equal sign,
Yes.
but not
Yes, just before
next
the
to
equal
each
sign
other.
there. Yes.
It can work, but just placing them next to each other, it makes it better. Yeah, so if you want to place
Okay.
the other one on the other side, you can, but it means that you have to place a positive one there because this is minus here. So if you place it on the other side, put it as a positive one.
So if it crosses the equal sign, it becomes positive automatically, yes?
Mm-hmm.
Okay. Then okay. So and the second question is what if I just leave it on let's see. Okay, without removing the square root there, I just leave it there on the brackets with a square thing.
Here.
So I don't know if it's yes, sir.
Ah,
Right
no,
there.
you haven't found the answer,
Would be
guys.
okay. Okay, so I remember we were being taught somewhere. So
Mm-hmm.
like the answer was just being left just there in the like completed square.
Um, that is when you're just completing the square, not solving a quadratic equation using completing the square, but just completing the square. Okay, so here we are solving an equation using completing the square. So we go all the way. But if you're just expressing something in completed the square form, then you just end you end at this point here. Just make sure you combine this. That's all.
Okay.
Yes. Okay. There's another question.
Yes.
Yes.
I wanted to ask, when coming up with a perfect square, just there where there are two colors where
Mhm.
you're trying to, yes. I'm asking about this after the x squared, the minus 7 over 2. I didn't understand how it was left out in the next, in the one in green. I just want to know what happens after that step.
Okay, so it means I have to show that part. Anyway, like just for a summary, I said as long as you put a correct special zero here, then the first three terms they form what we call as a perfect square. So a perfect square ignores whatever has x, it ignores it. It just combines these terms here with the squares. Okay,
Oh,
but
okay.
if you want to show it, you try to expand
No.
this one here. Okay, you try to expand this one, it will give you exactly what I have there.
Okay. So
Yeah,
it
but
always remains out.
yes, it just remains out. Like you forget about the term with the x.
Okay, okay.
All right, all right. Um, let's uh let's solve another one using the completing the square. So we just know the concept. Okay, so it's just the same thing for all the others there. So let's solve which one
Oh,
now?
sorry, sir. Sorry, sir. Question again. So
Mm.
this one you were just completing the square without finding the turning point in the other stuff and finding the
No,
graph.
no. Here we're
Just
just
the
solving the equation.
oh,
Mm. That one is
okay,
another
okay,
question
okay.
when we go for the graphing and the like.
Oh, okay, okay. I get it now.
Okay. Okay, let's look at part E. Or let me do part D. So part D, let's solve it using completing the square. Okay, minus 3 is equals to 0. So what we said is that, okay, always the coefficient of x squared should be what? A positive 1. So I'm going to divide throughout by a 4. 4 by a 4 by a 4. So that I make this coefficient here to be a positive 1. So what am I going to have there? I'm going to have x squared, okay, minus this 4 divided by 4, it just gives me 1. And then here I have minus 3 over 4 is equals to what? 0. Okay, so my equation has a coefficient of positive 1, and then now I introduce the special 0. So we said, how do we introduce the special 0? Okay, we get the coefficient of x. So in this case, my coefficient of x is minus 1. So that minus 1, the coefficient of x, you divide it by 2, and then you say what? Squared. And then this term that you have, you add it to the equation, and then you subtract it, okay, to form a special 0. So what we're going to have there is just x squared. Why am I writing with black? So it will be x squared minus x, and then now I add the special 0, right? So it will be plus minus 1 over 2 squared, and then I subtract this term, minus 1 over 2 squared, okay? And then minus 3 over 4 is equals to 0. So you've seen that this part here is just a 0. So I haven't changed anything, but it's just a special 0 written in terms of numbers, okay? And then what we said was that the first three terms now, as long as you've added the correct special 0, these first three terms, they form what? A perfect square. And how do we write a perfect square? We just concentrate on the guys with the squares there. Okay, it's called the perfect square for a reason. So we just focus on the guys with the squares. This one with the x, we just leave it out. Okay, so this one has a square, so I write x, and then I check whatever is inside the bracket there. So what is inside the bracket there? It's minus 1 over 2. Okay, and then I put this in brackets. I remember they both had squared, so I put a square like that. So we've written it as a perfect square. And then I remain with whatever has remained there. So that is minus, okay, um, minus 1 there. But if I distribute this power to the minus 1, I just get a positive 1. I distribute the power of 2 to the 2, that will be 2 squared. That will just give me a what? A 4. And then I have minus 3 over 4 is equals to 0. So this will just give me x minus 1 over 2 squared, okay? And then I can combine these terms. So that would be 4, because I have just the same things there. And then what is minus 1 minus 3? That will just be minus 4. Oh, I'll just write 4 there, not minus 4, because the minus is already there. Okay, and then this will just be equals to what? To 0. Okay, so we see that this part here is just going to become a 1, right? It's just going to become a 1. So meaning that what I have there is simply x minus 1 over 2 squared, okay, minus 1 is equals to 0. So this will be x minus 1 over 2. Someone has raised their hand. You can ask, is equals to 1.
I wanted to ask, there
Mhm.
where you have said the common denominator is 4,
Mhm.
and then we already have a sign which is
Mhm.
a negative that you've put down there. So
Mhm.
there's a negative sign where 3 over 4 is. How come you've said it's 4 again?
Okay, so those guys have similar. Maybe I should write it here. So I have minus 1 over 4, and then I have minus 3 over 4, right? This is what I have there. So I say common
Okay,
denominator here is
okay.
what? 4. So you've seen it?
No. Yeah, I get it. Okay.
Okay, so now that we have here is just the 1. So I'll say square root this side, and then even here square root. But here there's no square. So when I square root, I should have the plus or minus, I should add it. So that would be plus or minus the square root of 1. So this will be x minus 1 over 2 is equals to what? Plus or minus. What is the square root of 1? It is still 1. So we just have x is equals to, this minus half goes to the other side. So it is 1 over 2, okay? Plus or minus what? 1. So that's where we're going to get our two answers there. So actually, my favorite method is completing the square, because it's just straightforward. So it will be x is equals to, the first one will be half plus 1. Okay, so half plus 1, or it can be x is equals to half minus 1. So this guy here will be 1 over 2. Okay, and then the 1, I can write it as 2 over 2, right? So that my addition of the fractions is just simple like that. 1 is the same as 2 over 2. So this will just be the common denominator is 2. And then I add whatever is on top, 3. So my first answer is 3 over 2. And then on the other part, I can also do the same. This can be 1 over 2 minus this 1 here is the same as 2 over 2. Yes, someone has raised their hand.
Yes, sir. What if you just leave it on the x is equals to half plus 1 or x is equals to half minus 1? What if you leave it there?
No, you haven't found the final answer. You can easily combine this. So you can't leave the answer here. You have to finish it. You heard? So you have to finish it. Because why should you leave the answer there? Unless if your answer contains like a square root, something like that. Like you can't add the terms that you have, then you can leave it there. But if you can add them or combine them, just combine them to finish off the answer. Okay, so these are the two answers that we get there. So any questions there?
I still have a question.
Yes, please ask.
Uh, my que- my question is, I came a little bit late, but I wanted
Uh-huh.
to find out what's the difference between completing the square and completing the square method. I heard there are two types of things going on there.
What is the difference between completing the square and completing the square method? It's just the same thing. It's just that in some questions, you will be solving a quadratic equation using the completing the square method, which is what we are doing here. And then in some questions,
Okay.
you'll just be given a function. It's not, there's a difference between an equation and a function. I hope you know that. So an equation will be equated to a constant, like these ones. You can see they're all equated to 0, right? Okay, so we are trying to solve them
Mm-hmm.
using completing the square method, which is what we are doing. So now sometimes they can just give you a quadratic function that looks like this. Maybe x squared minus 6x plus 5. And then they ask you to express this in the completed the square form. Okay, they usually say express this quadratic function in the form A, and then they write x plus maybe b squared and then plus c. So they're simply asking you to turn this guy into something that looks like this. Okay, but what you do is the same thing that we've been doing here. Okay, it's the same thing that we've been doing. So they're just different questions, but what you're doing is the same. The other one, you're just expressing the function that you have in this form. Okay, but the other one, since it's equated to 0, like you are solving the equation to find the actual value of what? Of x. So you can see here in the process of finding the solving this equation, like using the completed square, you can see what we had there, right? You can see what we had there. It was like x minus 1 over 2 squared, and then minus 1 is equals to 0, right? So if there's a 0 there, then it is an equation. We're trying to solve for x. But if here there's no 0, meaning there's f of x there. So if, imagine we've put f of x here, then it will mean that I've expressed that f of x in the form a x plus b squared plus c. You can see that's what I have there.
Okay.
Yes. I don't know. Have you gotten
Okay.
it?
Yeah, I think somewhat almost there. Yes,
Okay.
you're saying that there will be no need for me to express it to 0, just put it to f of x.
Yes, some questions will just be f of x.
Okay. All right.
Yes.
Okay, that's okay. Thank you.
All right. So that's the difference there. So you guys like, yeah, so can you fail to complete a square or to solve a quadratic equation using completing the square? Can you fail to solve any of these that are here?
We can try despite it being long.
So the long one is what they want you to know. Okay, so you are forced to know the completing the square. So you have to know by fire, by force. You need to know. All right. So all right, so that's how to solve those. So those other ones, you can try them out at your own. You can send me your solutions. I check if what you're doing is correct and the like. And then the other concept that I wanted to do is actually how to graph using completing the square. So I'll do one question here. So where is that question? I think so such questions here. This one does not miss in the test one. It will be there. So if you haven't been practicing it, make sure you practice. Okay? How to express it. It's a good question for that guy who was asking just the previous question. You can say here, the question says, write each of the following function in the form f of x is equals to a, and then in the brackets I have x plus h, and then close squared plus k. And then once you express it there, sketch the following functions, clearly indicating the y, the x and the y intercept if they exist, because some of the quadratic functions that we're going to have, they're not going to have any x intercept, okay? But it will always have a y intercept. All right, so let's do that, okay? So they're saying write each of the following function in this form. So it is not different from whatever we've been doing. Okay, it is not different from whatever we've been doing. We're just trying to complete the square, but this time the equation is not equal to 0. Okay, this time the equation is not equal to 0. Where there was 0, now there's f of x. But what we're doing is the exact same thing. So let's start with the first one. So on A there, we have f of x is equals to x squared minus 4x plus what? 3. Okay, so I said before you complete the square, you always check the coefficient of x squared to be what? A positive 1. So we see here it's positive 1. So we are good to go. Okay, the next step is just to write x squared minus 4x, and then we form what? The special 0, right? So how do we form the special 0? You look at the coefficient of x. So the coefficient of x here is minus 4. So I'll say minus 4, and then this I divide it by 2, put it in brackets, and then I square it. Okay, so now get this term, add it and subtract it. But before we can even add it there, I think I can simplify this. This will just be minus 2 inside, right? So it will be minus 2 squared like that. So I'll say plus minus 2 squared, and then minus the same thing squared. And then what has remained there? It is a plus 3. Okay, so you see that this one here is just a special zero because it's the same thing, but I'm subtracting them. Okay, so I haven't changed anything in the equation. Okay, and then once you put the correct special zero, the first three terms here, they always turn into what? A perfect square. Okay, so for a perfect square, we said we ignore the term with the x, this one here. We ignore that guy, and then we just concentrate on the ones that have a square. So this guy had a square, and this one has a square. So they are the ones that we're going to what? To concentrate on. So what I'm going to have here to be equals to, this one has a square, so I write it. This one does not have a square, I forget about it. And then this one has a square, so you get the number which is inside the brackets there, which is just what? -2. And then you put them in brackets and then you square them like that. Okay, and then outside there, what do I have? I have minus, and then here it is -2 squared, so that will be 4, and then plus what? 3. So this will just give me x minus 2 squared and then -1. Done. So you've seen that expressing it in this form is just completing the square, right? And here someone has their hand. You can ask. Hello? Someone raised their hand.
Yes, sir.
Yes.
So on the same number, special number for -2 squared, uh, why can't we further what? And like leaving it, why can't we solve it? We leave it at 4.
Okay, why can't we? No, we are trying because we are trying to complete the square. So the terms that you have should be in terms of a square. No wonder we are putting two more squares there because we are completing the square. So we can't like solve it like to put it as to be 4 there. No. Then when what we're trying to do won't work. So we're trying to express it as a square because we're completing the square. I don't know if you understand.
Okay, I've
Yes.
heard.
And so,
Yes.
sir, this is where I was asking now.
Mm-hmm.
Yeah, so for functions, I will leave the answer with the brackets and the square,
Yes,
like
for
that. So
functions, we
for the
leave it like that.
quadratic, okay, so this is where I was asking now. Okay.
Okay. So now you can see that my f of x here is in the form that they wanted there. So meaning that what is my a here? My a will just be 1. Because outside here, the brackets, I cannot see any number. So here there's a 1. Okay. And then what is my h? My h is -2 because here they said plus h. So my h is this guy here. So that is -2. And then what is my k? My k is whatever is outside here, which is what? -1. So we've expressed it in that form. Okay, so we've done the first
Sorry,
part.
sir.
Oh, yes, you can ask.
Yes, using
Uh-huh.
the same function, what if you have maybe -2 as the value of x squared and you have to simplify it into this form?
Yeah, so that is B, part B, we'll do it. We'll
If,
see part B.
okay.
Yes. Mr. Vincent, you have a question?
Yes, sir. Thank you. Using the same equation, if we were asked to find the coordinates of the vertex, what number should we get? Is it -2, -1?
Yes, but I was going to explain that anyway. So now, what he's saying, what Mr. Vincent is saying, from this completed the square form, okay, how do we find the vertex? So the vertex is simply the turning point. So a quadratic equation, when you sketch it, it will always be either in this form or it will be in that form. So this part here, the lowest point, or this part, the highest point, is what we are calling as the turning point, okay? Or what we call as the vertex. So now, how do you find this to my vertex from the completed the square form equation, okay? So to find the x coordinate, okay, to find the x coordinate of the turning point, you always equate whatever you have in the brackets here with a square. You equate it to 0 and then you solve for x. So that will be x -2, because I have x -2 is equals to 0, and then x is equals to 2. So this is my x coordinate of a turning point, right? And then now to find the y coordinate of a turning point, you just always get whatever constant is there. So my y coordinate of a turning point will just be what is there outside. It's just -1. So I write -1. So meaning that my turning point will just be my x coordinate is 2, and then my y coordinate is -1. Yeah, so you can easily get the turning point from the completed the square form. It's very easy to get the turning points there. All right,
So is it
so
-2 or
huh?
for the turning point? Is it -2 comma -1 or it's 2 comma -1?
It's 2 comma -1 because we are saying this one here is the x coordinate. So the x coordinate is the one that starts, and then you go to the y.
Oh, okay, I've seen.
Okay. All right, so we found the turning point there. And then the question said we should also find the x-intercepts or the y-intercept, if any. So to find the x-intercept, we're just doing simply whatever we're doing when we're when we're solving the equation using completed the square. So to find the x coordinate, okay, we always say that y should be equals to 0. So this y here is the same as f of x. Okay, so to find the x-intercept, we just say f of x should be 0. Okay, so meaning at the points where the graph is going to touch the x-axis like that. So if this is equals to this, and then I want to find the x-intercept, I'll just say f of x is equals to 0. So it will be 0 is equals to whatever I have there. I can also write that as x minus 2 squared is -1 is equals to 0. This is what is going to help me find the x-intercept. Okay, so this one goes to the other side. So I have x minus 2 squared is equals to, this one goes to the other side. So that will be 1. And then I take the square root both sides. So I'm just going to have x minus 2 is equals to, here I just introduce the square root. So I get plus or minus the square root of 1. But the square root of 1 is just what? 1. So I just have plus or minus 1. So meaning that my x-intercept will be x is equals to 2 plus or minus what? 1. So x will be equals to, if I said 2 plus 1, it will be 3. Or if I say 2 minus 1, it will be what? 1. So these ones here are my x-intercepts. Okay, so the graph cuts the x-axis at 3 and at what? 1. Yes, sir, you have a question?
No, I want to add something.
Yes, you can add.
Yes, and apart from this formula that Tutor has taught us, there is another formula that you can use when finding the x-intercept. The same factorization method where you find the product sum and factor. So it should give you a negative and a positive in finding the coordinates.
Yeah. Yeah, so you can also use factorization method. So to find the x-intercept, you're just solving a quadratic equation. What we are doing on question 1, okay, to find the x-intercept, you're just solving a quadratic equation. So those are my x-intercepts. Let's find the y-intercept. Okay, so what do you think is going to happen when you're finding the y-intercept? Okay, when you're finding the y-intercept, it simply means x is equals to 0. Okay, so that will just be y is equals to f of x is 0 is equals to, and then what do I have there as my equation? Okay, I have x minus 2. So now where there's x, I'm putting 0. So that will be 0 minus 2 squared minus 1. And this will just give me what? Inside I'll just have a minus 2, and then I square it, I'm going to get 4 minus 1, I'm just going to get what? 3. So meaning that my y-intercept, okay, is at the point 0, 1. I mean 0, 3, like that. Okay, so to find the y-intercept, you set your x to be 0. To find your x-intercept, you set your y to be 0, just like that. Okay, so once we do that now, it means we can sketch this guy because we have everything that we need in order to sketch it. So, okay, and someone says, and the shortcuts for y-intercept, just get the number, which is 3. Yes, so you just look at the constant there, that will be the y-intercept. So I can say this is my XY plane. Okay, so you first plot your x-intercepts. So just plot the important things. So there's 1 there, and then there's 3. So don't start saying -1, 1, 1. No, no, no. This is just a rough sketch. Okay, so just plot the important points. So there's 1, there's 3, when it comes to the x, there's 0 when it comes to the x, and then the turning point is 2 comma minus 1. So meaning for the x, I also have like a 2 there. I have my minus 1 there. Okay, and then my y-intercept was at 0, 0.3. So 0, 0.3 can be somewhere there. Okay, and then you just plot these same points. So here there will be a point, okay? That is my y-intercept. My x-intercept are there and there. Okay, and then my turning point is at 2, comma minus 1. So that will be there. Okay, and then once you plot all those, you just draw a smooth curve through them. So the curve will come from there. So it will come from on top there, and then to come at this point it will turn and then to start going like that. Okay, so just draw a good one. I'm not good at drawing. So this is my f of x here when I sketch it. Okay, so any questions there? Okay, so there's no question. So let's do where we have a function which does not have a positive 1 in front there. Okay, how do we do it when it's just a function? Okay, so anyway, it is the same. So if I have a minus 1 there, or I have a 2, or I have a 3, it's the same approach. So there I'll choose B, and then you can try out the other one. So that is minus x squared plus 6x minus 5. So now remember, okay, when we are making the coefficient of x squared to be 1, when we are given an equation, let's say 2x squared minus 4x plus 6 is equals to 0. Okay, this is an equation. So to make this positive 1, I was saying divide by 2, divide by 2, divide by 2, divide by 2, right? This is what I was saying. Because this is equals to 0, so I can easily divide by 2. Okay, but now when you no longer have a 0 there, you can't say divide by minus 1, divide by minus 1, divide by minus 1, divide by minus 1. No, it won't work, okay? Because this guy here is not 0. So what do you do in such a case where you have a function now? So there you just have to factorize whatever number is there, okay? So that this can be a positive 1. And then the number you factorize from here, you also factorize from this, you also factorize from this. Okay, so here I see that in front I have a minus 1 there. So I'm going to factorize the minus 1. And then in brackets, I'm going to have x squared with a positive 1, you can see there. And then since I factorize the minus 1 from here, I also factorize the minus 1 from where? From there. So that would be minus 6x. If I factorize the minus 1 from here, I have plus 5. That is what I have there. Okay, so always make sure that if I multiply with the number that is outside here, I get back my original. So minus 1 multiplied by this, I get back this. Minus 1 multiplied by this, I get back this. Minus 1 multiplied by this, I get back this. Okay, so from there now I'm going to say minus 1 outside, and then in the brackets there, I can complete the square. Okay, I can complete the square. So that would be x squared, okay, minus 6x. Okay, and then we form the special 0. So how do we form the special 0? Okay, we look at this guy here. The coefficient of x is minus 6. I divide this number by 2, and then I say in the brackets, square it. So it means here I'm just going to have a minus 3, right? And then I square it. So I'm going to add and subtract this term to form my special 0. So it will be plus minus 3 squared minus 3 squared. Okay, and then I write whatever was there plus 5 like that. So I haven't changed anything. I've just written a special 0. Okay, so as long as you've written the special 0, it means the first 3 terms here form a perfect square. So it's always the same thing. Okay, so this will be equals to minus 1 outside brackets, and then this guy is here. Okay, they form a perfect square. So it will be x. This guy, I forget about him. I get whatever is inside there. That is minus 3. And then squared. And then here I have minus, this minus here. And then what is minus 3 squared? So minus 3 squared, it's simply 9. And then I have plus 4. Okay? Okay, and then once you do that, now you can combine this. Okay, so it will be minus 1, x minus 3 squared. And then this will give me minus 4, like that. Okay, and then once you have done that now, you can multiply with the number which is outside there. So in this case, we have a minus 1 outside. But in some case, like this one, you have a minus 2, this one, you have a minus 3. So you multiply throughout by that same number. So what am I going to get? I'm going to get minus 1 multiplied by this. I'll just have a minus in front of this, and then x minus 3 squared. Then minus 1 multiplied by this, I'm going to get positive 4. Okay, so this here is expressed in the form that they wanted there. Okay, so we can pick out those to my constant that they said. So what is my a? I see that outside the bracket I have a minus, so my a is minus 1. Okay, my h is whatever is combining with the x, which is just minus 3, and then my k is what? The constant which is outside, which is 4. So I've expressed this quadratic equation in the form that they wanted there. Okay.
So,
Yes.
why did you put -3 on that one?
On where?
-3. When you say -3,
Like
aren't
here,
we supposed to multiply? Oh, no,
this one here.
our answer. Yeah. Yes.
Oh, so this negative here cannot go inside here because this guy is being squared. So it cannot just go inside direct, no. So it is outside here. It does not multiplied with the x, it does not multiplied with the 3. It is outside the brackets.
Oh, okay.
Yes.
Okay. All right.
Okay, so that is completed. We have completed the square. The next thing is to find the turning point. Okay, so the turning point is very easy. You just look at whatever you have here. Okay, so to get the x coordinate of a turning point, we say whatever is in the brackets here equate to 0, so for x. So that will just be x minus 3 is equals to 0. So for x is going to give me x is equals to 3. Okay, and then uh, my y coordinate of a turning point will be what? Will just be this guy here, the constant. So that will be 4. So my turning point is 3, 4. Okay. And then what else should I find there? I should find um, the x-intercept and the y-intercept. So for the y-intercept, we know. We said it's just to get the constant there, right? That would be like my y-intercept. So the constant there is just minus 5. But if you want, you can try to put 0 there, 0 there. You still get minus 5. Okay? Still get minus 5 there. So meaning that my y-intercept is going to be at 0, minus 5. Okay, so we are just remaining with the x-intercept. So for the x-intercept, we get this equation, we equate to 0, so for x. That will be minus x minus 3 squared plus 4 is equals to 0. This guy goes to the other side, so I have minus x minus 3. Yes, you can ask your question, minus 4.
Yes, the question is on y-intercept. The negative 0, negative 5.
Uh-huh.
Negative 5 is coming from the equation, and
At what?
to find y after turning point. I've seen 0, negative 5. Is it coming from the equation or?
Yes, because this is the y-intercept. So we said the y-intercept is always at 0, comma, the constant term in the equation that you were given. But you can retry to find this. So to find the y-intercept, we said we just have to replace in our equation that we've been given, wherever there's x, we put 0. So if I put 0 here, it will just be 0 squared, 0. If I put 0 where the x here, it will be 6 multiplied by 0, 0. So I'll just remain with what? I'll just remain with minus 5 there. That's where the y-intercept is coming from.
Okay, thank you.
Yes. Okay, and then the other thing now is we're finding the x-intercept. So for the x-intercept, I said the fx becomes 0 because I'm finding the x-intercept. Okay, so this is what I'm trying to do. So I have this guy plus 4 is equals to 0, and then I take this guy to the other side. So here now I can divide by minus 1. Even here I divide by minus 1. So what I have is x minus 3, okay, squared is equals to what? Is equals to positive 4. Then I take the square root on both sides. I'll get x minus 3 is equals to plus or minus the square root of what? 4. So meaning that x minus 3 is equals to plus or minus what? 2. So this will give me x is equals to, this guy goes to the other side, so it will be 3 plus or minus what? 2. So x will be equals to 3 plus 2, that is 5. Or x will be equals to 3 minus 2, that will be what? 1. So my x-intercept at x is equals to 1 and x is equals to 5. Okay, I have my y-intercept, I have my turning point. It means I can sketch this guy, right? Okay, so let's sketch him. So it will be the y-axis there, and then here I have my x-axis. Okay, it's just a sketch. So you can say I have my 0 there. Then I plot my x-intercept. So my x-intercept are 1 and 5 somewhere there. Okay, and then what is my y-intercept? My y-intercept is 0, comma minus 5. So 0, comma minus 5, the minus 5 can be somewhere there. So this is my 0, comma minus 5 there. Okay, this is my x-intercept 1, this is my x-intercept 5. So now, am I remaining with? I'm remaining with a turning point. So the turning point here, it is at 3, comma 4. So definitely the 3 is between 1 and 5, right? So maybe the 3 is somewhere there. Okay, and then when I go to the y, my 4 can be somewhere there. So my 3, comma 4 will be somewhere there. So that is my turning point there. Okay, and then this is my x coordinate, intercept, x coordinate, intercept, and then y intercept. So how can we draw now my sketch? Okay, my sketch should always follow the turning point and then it will go back to where it came from. So this one will just start from below here, passes to the turning point, then it comes like that. Yeah, so you can draw a better one. So this is my f of x. And we are done. So any questions there? Okay, so if there are no questions, okay, if there are no questions, I'll end here for today. I hope you guys have known how to complete the square and how to sketch by completing the square. What we're doing here is sketching by completing the square. So make sure you try out the other questions. So you can try this, try this. You can send your your solutions to me. I'll be able to check them out if you're doing the correct thing. But definitely, it doesn't miss in test one. This question will be there. Okay. So if you manage to understand the whole question, you've already gotten marks in what? In test one. All right, guys, have a blessed night.
Thank you, sir.
Thank you,
Thank
sir.
you.